Some students give me a feedback to say they cannot get a result based on the instruction from these slides, and I will give you the more details on how to use the Excel server in the next few minutes. But before we go to the Excel, we need to understand the reason why we have to use this a little bit more complicated method. In the previous lecture, we have introduced several different methods to help you to do the investment decision. For example, like the net present value or the internal rate of return. However, for both of them, they have their own weakness. For example, like in this example, if we see the net present value, we need to choose the project 2 because it gives us a higher net present value. However, if we see the internal rate of return, you can find for all of these three projects, their internal rate of return, they are exactly the same, which means we cannot rely on the internal rate of return in this example. Let's carefully check what is the details for these three projects. Actually, you can see the second project is only the twice of the project 1. And for the project 3, it is only the 1.1 time of the project 1. That means the net present value, they are always suggest us to invest in the bigger project because its net present value is higher than the rest of them. If we don't have any constraint, that is okay, which means you can always go to the bigger project. But when we calculate a portfolio, that means there is a constraint for how much money you can invest it, and it is not only on one project; it could be in different projects. We need to find some other solutions because net present value does not work in this case. So what we do is we have the two solutions. First solution is based on the profitability index. And before we go through the details of this example, let me tell you, this example is from this book, The Financial Analysis with Microsoft Excel. If you are interested in the details of this example, you can go through that book. In this example, we have 12 projects, and all of them has a different cost and different net present value. We can use a profitability index to choose which project need to be included in our portfolio, and that is solution in here. When we're using the profitability index, we need to calculate the profitability index first, and then we need to sort them from the biggest to the smallest. Because for the profitability index, it means for each dollar how much money you can earn from this project. This is the best solution we have? Apparently, it is not. The reason is we want to introduce another method to use. That is, we are using the linear programming method from the Excel, but actually it's not really from the Excel. It is a kind of a mathematical method. When you're using the linear solver in the Excel, there are several tips. First one, you must understand what is given by the question or by somebody. And for this example, the cost and the net present value, they are the data from somebody else. And then you need to input them into the Excel. And then you need to make sure you have downloaded the add-ins into your own Excel. So please find the add-ins and make sure you have downloaded the server add-in. I'm using a Mac, and it could be different with the Windows, but it should be slightly different, so you don't need to worry about it. And of course, you have to choose the best option, the right one from the menu. And then after that, you need to calculate the total cost and total net present value. When you calculate the total cost, this equation does not work. The reason is the Excel, they don't understand what is your idea. So what you need to do is when you enter this equation, you have to use the Shift Control plus Enter to enter this equation. What is the meaning of this equation is you use the B4 times the 4 and use the B5 times the D5, and then you sum them together. And that is for the total cost, and you need to calculate the total net present value in the C17. And then after that, you need to set up the solver. When you set up the solver parameters, the set objective is the C17. That is the C17 here. And finally, the solver parameter will give you the result in the D4 to the D16. In the D4 to the D16, this is a binomial variable. That means they have only two values, 1 or 0. So which means 1 times net present value, it means you have included this project. 0 means you don't include this project. And the second and the first constraint is the B18 should be bigger than the B17. That means your total investment has to be smaller than your constraint. And the second constraint, that is for the D4 and the D16, they has to be bigger or smaller than 1. That means you cannot invest in a project twice. So you have to invest in one project, but not twice. And for the third one is for the D4 to the D16, they must be a binary variable. It has to be the value of the 1 or value of the 0. And finally, for the binary variable in here, they cannot be a negative value. That is the constraint for the solver parameters. However, in here there is a tips, that is you have to choose the LP, that is the linear programming. And when you choose the options, there is an option is ignore the integer constraints. Ignore the integer constraints, it means if you choose ignore the integer constraints, that here the value could be a fraction. A fraction, it means you can invest it in a project, but only in part of them. But for this example, will not allow you to invest in part of the project. So please make sure you didn't choose the ignore integer constraints. And then if you click OK, and if you click the solver, they will give you the different value. They will give you the result in here. Let's try I put all of them to be the 1. That means I included all project. And of course it does not work. The reason is the total investment is bigger than the constraint, which means I cannot invest it. I don't have those money to do the investment. And now what we do is I choose the solver, and then ask the Excel to solve the problem, and they give me the feedback is okay. Some of the project is included, some of the project does not included. And let's see whether the linear programming is better than the profitability index. The answer is yes. So you can see the cost is 2.9 million, and in here is 2.7 million. So that is better than the profitability index. And for the net present value, this is 466, but in here it's only the 328. So that means the linear programming method, it works, and it gives us a better result from compared with the profitability index. And I hope this is useful to you. Thank you.